Okay, ladies and gentlemen, another gas law to explore, Gay-Lussac's law. This is where you see a change in pressure and temperature and how that impacts the others, where volume is held constant. So this time we're holding volume constant. Let's begin. Before I begin, I wanted to mention again, like similar to Charles' law, you will see a formula like this often in a textbook or in the internet. All I've done is cross-multiplied this and made this more of a linear equation just to make the math a little bit simpler in my opinion. So here in example 13, we have a pressure, looking for pressure. We have a pressure given right here of 1 atm, and we're looking at a temperature change from 20 degrees Celsius to 30 degrees Celsius, similar to in Charles' law and every law that we do in here. All temperatures must be in Kelvin, so I took the time right here to show you how I converted both of those into Kelvin. Then I'm going to plug things into the appropriate formula. I want to talk about the formula, which I did not mention yet, but it's important to mention it here, that yes, we have P1T2 equals P2T1. So once again, the T's seem to be in the wrong spots, but they're right where they're supposed to be. A T subscript should be different than the P or the V subscript when they're next to each other. So this is the correct formula. Be very careful where you plug T's in. That's the common mistake that my students make, so be triple careful. Triple, double, whatever, quadruple check, make sure you're putting your T's in the right spot. So we have 1 atm here, P1, times T2, remember this is our T2, and I had to convert it into Kelvin, times T2 equals P2 times T1. This is T1, it was 20 degrees Celsius, but I had to convert it into Kelvin. So now I'm going to multiply these two numbers on the other side. Oh, before I do that, I apologize. We should pause and say, what do we have two of? We have two temperatures given. They're both in Kelvin, so we can proceed with our math. So therefore, I can say that these two numbers are together. My unknown's on the other side. There's no unknowns on the left side, so I'm going to multiply that side, hit equals, and then divide this over to get P2 by itself. When I do that, I get 1.03 atm. Please pause your screens and check through the math. Remember that you need to have the generic formula, numbers with units plugged in, and a final answer with units. So pause, see if you can get my answer, and then begin the video again. Okay, hopefully you're back now. Let's look at the general characteristics and change here. We went up in temperature, and we went from 1 atmosphere to 1.0 atmospheres in pressure. So temperature went up and pressure went up, which should be consistent with the things we've been talking about throughout this unit. They are directly related. All right, example 14, here we are. We've read this word problem. I come across this. I recognize that it's a pressure, and this is my temperature together, so I'm making them my ones. And it wants to know what is the temperature later if it gets to standard pressure. Remember, standard pressure is any of those pressures that we use in our conversions. Because we're already using mmHg, I pick 760 mmHg. Just makes it more easier. I don't have to do any don't have to do any conversion tables, and then I have to also remember to convert my 40 degrees Celsius into Kelvin by taking 40 degrees plus 27316, so I get 313.16. So here we have the next thing here. Let me pause this. I'm not sure if you're seeing this other thing on my screen. Okay, welcome back. I was trying to get this thing you can barely see over here out of the way, so that's what I did. Sorry about that. I got distracted by that. Okay, I just didn't want it to be in the way of anything. Now back to this problem. So P1 is going to be 699 millimeters of mercury. T2 is what we're looking at. Remember, the T's are in their odd spots. We're looking for T2. That's what we don't know. We know we're at standard pressure for our second pressure, so it's going to standard pressure, which is 670, and our T1 is this temperature right here, and we converted it into Kelvin, so we put it there. I was very careful to put my T2 here and my T1 there. The unknowns over here, but before I do any math, I'm going to pause and say, what do I have two of? I have two pressures. They are in fact in the same unit, so no reason to convert them, so now we can do the math. I would kind of just look at these problems and say, where's my unknown? My unknown's on the left this time. So then I'm going to take everything on the right and multiply it because I have no unknowns over there. When I multiply those two, I'm going to hit equals and then divide by 699 to get T2 by itself. You should be able to get 340.49K. Please pause your computer and go through the math. Remember, you need the generic formula, the numbers with units plugged in, and an answer with units. Please pause and do the math on your calculator. See if you can get my answer. Thanks. Okay, welcome back. Let's just talk about the trend here. We see that pressure went up from 699 to 760, and we see that temperature went from 313 to 340, so they in fact did the same thing because we know that pressure and temperature are directly related. As one does one, the other does the same. Let's go on to the next example. All right, in example 15, we have a pressure value, and it tells us that at this pressure, it's this temperature, standard temperature. So that's going to be the 273.16. Right here, I put it right there for you on the screen. And it's going to go from standard to 67.84 Celsius. Remember, I can't function in degrees Celsius, so I must convert this into Kelvin. I did that right here. It wants to know what is the final pressure later on. So we're going to plug in our P1, 903.5 torr, times our T2, remember it's T2, which is the other temperature that I converted into 341 Kelvin, equals P2 is what we're solving for, times T1, remember T1 was standard, so 273.16. I'm going to pause and say, what do I have two of? I have 2 Kelvin, or 2 temperatures, they're both in Kelvin. 2 temperatures are both in Kelvin, so I can go ahead with the math. I notice that my unknown is right here, so that means I'm going to use the other side first. I'm going to multiply these numbers because there's no unknowns there, and I can multiply them, hit equals, divide by 273.16. When I do that, my Kelvin temperature would cancel, leaving me only torrs, and we get 1127.89 torr. As always, please pause the video. Make sure you give me the generic formula, numbers with units plugged in, and an answer with units, and then please check your math and then start the video again. Okay, let's see what happened here. We saw an increase in temperature, 273 to 340, so we should see an increase in pressure, and in fact we went from 900 to 1100 something in torr. So we did see that it was directly related once again. All right, final example for this set. We are starting at standard temperature and we're going to a pressure of 209.45 kPa. Wants to know what is the pressure later has a pressure of 0.345 atm. What is the later temperature? Formula is always P1T2 equals P2T1. I'm going to plug in my P1. I don't have T2, that's what I'm solving for. I have my P2, and then I have my T2, or excuse me, my T1 over here. So we know that we got to pause and say, what do I have 2 of? I have 2 pressure units, but they're in different units. I'm going to convert ATM to kPa. Let's do that in a grid. So here is the grid that we needed to do. We put 3.3456 ATM. We know 1 ATM equals 101.325 kPa. Do the math there. I get 3502. We're going to substitute in that number right here. Now my the things I have 2 of, 2 pressures, are both in kPa. Now units will cancel, so I can do the math. I see that T2 is over here on the left, so I'm going to multiply the numbers on the right and bring them over. Remember, when I bring them over, the unit would be kPa K. So when I bring kPa over, kPa's will cancel, leaving me just Kelvin. I showed that the wrong way on the screen. I'm sorry. I'm going to multiply those and bring this over. Multiply these 2 and bring this over. And I'd solve for T2. When I do that, I'm going to get 45.67 Kelvin. Please pause the video. Make sure you show me the generic formula, the numbers with units plugged in, and the answer with units. Go ahead and check your math. Make sure you can get my answer, and then restart the video. Okay, let's see what happened here. Here we saw a decrease in pressure, right? Because I got to look at the same units when I'm looking at it. A decrease in pressure, and we saw a decrease in temperature. So that makes sense because we know that pressure and temperature are directly related. Thank you very much, and now you can go to the next assignment.